This is from Mathematical Methods. It comes out of Chapter 10, 10b, question number 13. A particle is moving in a straight line so that position vector x relative to the origin is given by this. So x equals 2t squared plus 2 to the half. I've asked to find the velocity as a function of t, acceleration as a function of t, remembering that this is position as a function of t, and then the velocity and acceleration when t equals 1. Okay, so looking at the textbook, I can see that the position, velocity, and acceleration are given by the velocity is the derivative of position, and acceleration is the derivative of velocity. So since I've been given position, so if I could take the derivative dx dt, that will be velocity. So this is dx dt, and this one is dv dt. Okay, so the first derivative is dx dt. That's going to be, I've got a chain rule happening here. I'm taking the derivative with respect to t, so it's going to be a half times that something to the negative a half, and then the derivative of the inside is 4t. So that's going to give me 2 cancels with the 4, 2t squared plus 2 to the negative a half, and that will be v, velocity. So for part A, v equals 2t on top of the square root of 2t squared plus 2. That's the first part. Looking at the second part, acceleration is going to be the derivative of velocity. So I need to now take the derivative of this. But if I'm going to take the derivative of this, I've now got a product rule. So u equals 2t, therefore u dash equals 2. And v equals 2t squared plus 2 to the negative a half. Therefore v dash will be negative a half 2t squared plus 2 to the negative 3 on 2 times 4t, which will be negative 2t squared plus 2 to the negative 3 on 2. So putting that together, v should equal, dv dt should equal this times this, so minus 4t squared. So negative 2 times 2 is negative 4, t times t, times 2t squared plus 2 to the minus 3 on 2, plus this one times this one, which is 2t squared plus 2 to the negative a half. And I'd like to take out common factors. I can take a 2 out. I can take a 2t squared plus 2 to the minus 3 on 2, because minus 3 on 2 is smaller than minus negative a half. I've taken the 2 out, so that gives me minus 2. The t squared still in there. All of that's gone. Plus, I took the 2 out, and I've got 2t squared plus 2 to the power of 1. Minus 2 t squared and t squared cancels, and that will leave me with 4 times 2t squared plus 2 to the minus 3 on 2, which cleans up to equal acceleration is going to equal, and that's going to be the expression for acceleration, 4 on top of 2t squared plus 2 to the 3 on 2. So that's part B done. Part C said find velocity and acceleration at t equals 1. So where's my acceleration? There's my velocity. So when t equals 1, it's going to equal 2 on top of the square root of 2 plus 2 is 4, which is 2 on 2, which equals 1. So part C, when t equals 1, velocity equals 1, and acceleration will equal 4 on top of 4 to the 3 on 2, which is 4 on top of 2 cubed, which is 8. 4 on 8 is a half. Acceleration equals a half. And And do we have any centimeters per second? So that's centimeters per second, and that's centimeters per second squared.